Hi all, welcome to the another video of subject DC machines and transformers based on the KTU syllabus, and we are on module 2, and today we will discuss about the commutation process. So as we know, the commutator and brushes are very important parts of a DC machine. So the main functions of this commutator and brush assembly are the passage of current from a moving armature to the external circuit and the change from a generated alternating current to an externally available direct current. Actually, this process is called the commutation. Okay, so actually it is the reversal of current in the armature coil. Okay, reversal of current. So here as one of the armature coil rotates, okay, as one of the armature coil rotates, we know that the current will flow through that coil, okay, and then this coil is short circuited by a brush for an extremely short fraction of a second. That is, we can say that around 1/500 of seconds, okay, a small fraction of a second, and after which it passes into a region where the current reverses. Okay, so previously the current will flow in such a direction through a coil, okay, but when the brushes short circuited the coil, and after that the current direction will reverses in that coil. Okay, so actually that process is called commutation, and good commutation means no sparking at the brushes and the commutator surface remaining unaffected during continuous operation of the DC machine. And in the case poor commutation means there is sparking at the brushes and the commutator surface gets damaged during the machine operation. Okay, so uh, if the coil, okay, if the commutating coil is not short circuited at the correct instant, there will be a possibility of sparking. Okay, so it will damage the commutator assembly, okay, and the machine assembly. Okay, so the period during which the coil remains short circuited is called the commutation period. So using these 5 figures we can explain the commutation process. Okay, so if a question comes based on the commutation, you have to draw these 5 figures, okay, at least these 5 figures, and based on that we can explain the commutation process. So initially, as shown in the figure A, 6.8 figure A, you can see that here all the current, okay, all the current from the armature path which is to the left of the brush, here the brush is located on the B segment, B commutator segment B, okay, and all the current which is to the left of the brush passes through coil B. This is the coil B, okay, coil B, and all the current from the armature path which is to the right of the coil, okay, which is the right of the brush, passes through the coil C. This is the coil C. Okay, so here the current is passing through the coil A and it is goes to the coil B, but here there is a connection to the commutator segment A, but here the brush is not in contact with the commutator segment A, so the current will not flow through the external circuit. Okay, so the only way is to flow the current to the external circuit is this one, A to the B and to the commutator segment B and to the brush and to the external circuit. Okay, so here IC is coming from the left side and also the IC is coming from the right side. Okay, here also IC is coming from the right side. Okay, so in effect 2 IC, total current 2 IC will be flowing through the commutator segment B and the brushes to the external circuit. Okay, so this is the initial condition we are assuming, and we are assuming that the machine is rotating. Okay, machine is moving to the right side. Here's the motion is to the right side. Okay, the brush is fixed, this winding and the commutator assembly is moving to the right side. Okay, just assume that. So in the next figure B, okay, in the next figure when the brush is just starting to be in contact with the commutator segment A, that is the bar A. Okay, so there are now 2 paths to the brush for the armature current coming from the armature path. through the commutator bars A and B. There will be two paths. Okay, that is one through the commutator segment A and another through the commutator segment B. Okay, so here IC is coming through the coil A, and here a small amount of current. Okay, that is here a small contact is made in with the commutator segment A. So IC minus X, if X is flowing through the coil B, IC minus X will flows through the commutator segment A and through the brush, and remaining here is IC. IC is coming from the coil C, and along with the IC this X is also there. Okay, so IC plus S, IC plus X is flowing to the commutator segment B and through the brush. So in effect, when we are adding these two, IC minus X plus IC plus X, of after that also we are getting the resultant current as 2IC. Okay, resultant current as 2IC. So here, as the area of contact with the bar A, that is commutator segment A, increases, current flowing to the brush via the commutator bar A increases, and current via commutator bar B, commutator B will be decreases, as the area, as if the machine is moving to the right side, of course the area of contact with the commutator bar A increases, B decreases. So likewise the current through bar A increases, bar B will decrease. Okay, and in the next figure C, okay, you can see that here the brush contact areas are equal on bars A and B. So each bar delivers a current of IC. That is, the first path is through the coil A, this IC through the commutator segment A and to the brush, and another path is through coil C, IC is coming here, and through commutator bar B to the brush. Okay, so in that case also the resultant current is 2IC. So here all the current from the left side is flowing through the commutator bar A, and all the current from the right side is flowing through commutator bar B. So in effect the coil B, here the coil B, capital B, okay, the coil B is short circuited by the brush here. So there is no current. Okay, the coil B carries no current here. Okay, so the brush contact area on bar B starts to decrease here. Okay, in the next figure D, starts to decrease with the further rotation of armature, and the current delivered by the bar B decreases, and the coil B, here the coil B carries a current of Y amperes. Okay, that is IC is coming here, and the more contact area, okay, contact area with the commutator bar A is more compared to bar B. So here IC is coming through the coil C. Okay, it is divided into two, that is Y and IC minus Y. If Y is flowing through the commutator, sorry, the coil B, IC minus Y will flow through the commutator bar B and to the brush. Okay, and here IC is coming through the coil A, and it will add with the current from the coil B Y. So IC plus Y, here IC minus Y. Okay, so these two current is flowing through the brush here. In effect, if we are adding these two, we will get a resultant current of 2IC. Okay, so here you can see that in the early case the current through the coil B is to the right side. Okay, we can see this, the X is also to the right side. Here initially it was IC, and it is reduces to an X value here, and again the current flowing through the coil B reduces to 0 here, and after that the current reverses. That is, current flowing here, the Y current is flowing to the left side here. Okay, the direction reverses. Okay, and if in the next figure the brush is, okay, fully connected to the commutator bar A only, A alone. Okay, it is not connected to the bar B here. Okay, bar B here. So current from coil A and current from coil B, IC plus IC, 2IC, the resultant current 2IC will flow through the commutator bar A and brush to the external circuit. Okay, So thus during the period of short circuit, that period is called commutation. The current in short circuit coil should be reversed to full value. Okay, reversed to full value. If it is not reversed, there will be a sparking effect. Okay, it may cause a sparking there. That is, if the current in coil B does not attain its full value in reverse direction, by the end of the short circuit, the difference between the current through coil B and C has to jump from the commutator bar B to brush in the form of an arc. Okay, if that reversal is not completed, okay, there will be a possibility of an arc between the brush and bar B. Okay, so actually this is the entire process of commutation. I hope all of you understand the process well, and the explanation is written here in the slides. Okay, you can also read from the slides. So thank you.